Thank you for joining today's webinar on how to achieve secure CDL through threat modeling. Today's webinar is hosted by ThreatModeler, a signatory of the Cybersecurity Tech Accord. Last year, the Tech Accord announced a new partnership with the Global Forum on Cyber Expertise to strengthen cyber capacity building through the exchange of best practices. To further our commitment under that umbrella, we launched a series of webinars to help increase the understanding of key cybersecurity topics, such as the one you will hear today. Today's webinar is presented by Alex Bauert, Senior Director of Threat Intelligence at ThreatModeler. Alex has more than 25 years of IT experience, with 15 of those years spent in architecture and application security leadership roles. Alex is currently the Senior Director at ThreatModeler's Research Center, where he drives the maintenance and updating of the threat intelligence framework. We welcome you to share any questions you may have using the chat box located to the right of your screen, as there will be time at the end of the presentation to address questions. And now I'd like to welcome Alex.
Thank you so much. Thank you all for joining us. This is Alex Bauert with ThreatModeler Software. We're looking at some pretty big topics here for kind of a short amount of time. So we're going to go through a lot of material. There'll be some material in the slides that may not get a lot of in-depth talk. So bear with me as we try and get you the basic information that I think you need to know about threat modeling cloud. What I'm going to try and cover today is a little bit of basic or refresher knowledge, probably stuff that you're all very well aware of, just adapting to the cloud. We'll talk a little bit about cloud development lifecycle and whether that that is fitting specifically your direct approach of development lifecycle, where we'll talk about it a little bit generically and how threat modeling fits into that. We'll touch on threat modeling basics, how to, why, and then I want to talk a little bit about the value of threat modeling in general, but also in cloud deployment. So we're finding ourselves adapting to this movement of migration to the cloud. And it's at core driven through a need for demand-based technology delivery. It really hits on the evolving business requirements that are driven in efficiency and cost management. As we've moved to the cloud, we are finding ourselves needing to re-architect. And not only are we re-architecting what the technology looks like, but also we're having to re-architect how we're delivering that technology. And that re-architecting isn't just a technology re-architecture, it's a process, a methodology re-architecture. In this, though, from a security standpoint, our big picture rules and policy requirements and controls haven't necessarily changed. What's changing, though, is how we're implementing them, and that continues to evolve. And there are two base layers that we're looking at this new construct. Infrastructure, and those are the cloud services, what the cloud service provider is bringing to the table. And that can be infrastructure, it can be componentized or modularized services that it used to be we would be creating and providing, and we as on-premise data centers, as well as applications themselves. They may have full-blown applications that are coming through the cloud that we're making use of, but we're also building and we're rebuilding our applications in that cloud space. So a lot of the risks at a high level haven't really changed, but the technology changes and these methodology changes have added new threats or in some cases, they may not have added threats, but they have brought different ways of leveraging or exposing those threats. So as we're adapting, we're still having to deal with these same security practices that we had in our, we'll call it our old style of doing things, security practices like identity management, incident response, infrastructure security. But with this evolution, we're starting to see two new areas really maturing, and that is implementation of security in your CI/CD. You can look at that as DevOps, DevSecOps, and the big data aspect. We've gotten really good at collecting more and more data, and so the question is, as we're collecting all of this additional data, what are we doing with it? And so big data analytics for security data is a growing and necessary place to invest and focus in. And it's particularly true with cloud, since the cloud providers are adding to that data from their own resources. And so we're now looking at how do we, not only what data are they presenting us, but how are we better able to consume that data and actually do better with our risk management decisions. One bonus in this, though, is we now get to share this burden with the cloud service provider. And that's kind of a double-edged sword. In adapting or adopting to cloud technology, one thing to keep in mind is that as this has sped up, it's made collaboration an increasingly important word to integrate into all of our processes. We've got multiple stakeholders, and all of these stakeholders need to be participating in the security equation. And if we don't get that collaboration, we'll find that we won't be able to manage the speed that the business is requiring for delivering the technology. So I mentioned a moment ago that we're looking at the bonus of sharing this with the security practices and obligations with the cloud service provider. And keeping that in mind, we really need to look at the shared responsibility model in the cloud and how that plays a part. In this environment, we're looking at a slew of technology that is being brought to the table that we are allowed and able to consume, but we have limited control over that. And then there's the technology that we're bringing into the environment over the top of these underpinning services that the cloud service providers has brought to us. What this does is it really segments who's doing what or who's responsible for what. And the shared responsibility model should be something that we are keenly aware of, and that we're taking that and applying it to all of the different areas of information security that we're practicing. For threat modeling standpoint, you want to be able to identify here which threats are we responsible for and which threats is the cloud service provider responsible for. And being able then to look at who's bringing the controls to mitigate those threats. Are the threats being addressed by the cloud service provider, where they are threats that are coming in from their infrastructure? Are the threats coming from our new technology or applications or services that we're providing in the environment? And are they addressed by controls that we have to bring to bear? Or are they controls that we can pull in as cloud services as well? So I want to bring forward here the cloud development lifecycle as a generic pattern. You'll see that there's a real similarity here with what we've seen as a traditional software development lifecycle. There are other other ways to slice and dice this. There are probably CDLCs that are much more complex or showing a much deeper set of different activities or components. But let's just talk about it in terms of these four phases. And you'll notice that I've got threat modeling in the design phase. Threat modeling is a security practice that is really intended to be done as part of the planning and the design. As we're moving through this, you want to keep in mind that cloud service providers like AWS and Azure are also engaged in their own CDLC. Now we're paying attention to this as we're doing infrastructure development and deployment, or as we're doing software development and deployment. But that same cloud service provider is also engaged in this, and they're continually releasing improvements and new tools and services that include things like a variety of security and identity management services. So while we're paying attention to what we're doing, our foundation is also continuously and rapidly changing. So as IT organizations, we have to stay on top of the cloud providers' changes, the latest services and features that they are deploying. We need to have a clear understanding of how that affects our security landscape. And that in itself can become its own full-time job, just keeping up with your provider. In threat modeling, and we'll dive a little bit more into some of how the threat modeling lays out. But one of the key things that comes out of it is an understanding of the controls. And I just wanted to preface some of this discussion with looking at a basic way of looking at our controls. We have the directive, preventive, detective, and responsive controls. And if you were to look at that from an operational standpoint, really the detective and responsive controls are pretty much all about validation. And if you consider that it's validation or assessment, then these controls, which are most often engaged in late stages of the life cycle, you're looking then at identifying the problems once you're potentially already made critical decisions, or worse yet, once you're already in production mode. And so now these security issues are fully presented in the public. So one thing that we want to be, that we really want to be focusing on is how do we change this equation? Now, this is something that we've in software security, application security, have been talking about for a long time, and it's now being discussed as the shift left movement. And what it really is taking everything to a point where you have a focus on your directive and your preventive controls. And the directive and preventive controls are happening during design, ideally. Now, you may have actual implementation of the control happening during the production deployment, but the planning, the decision making around the implementation, or the need for the preventive or directive control is really something that needs to be done in that planning stage. All right, let's since there's still quite a bit to talk about, let's go into a little bit about threat modeling itself. Why do we do threat modeling? So very often I'm hearing debate around, well, why should we be doing threat modeling? And the essence of it isn't because it's being mandated by PCI DSS or because Some practice book said, "Thou shalt do threat modeling." Threat modeling has some pretty specific outcomes, and primarily among them are you get an increased view of the technology stack, you get a better understanding of not only what the security threats are, but you also start understanding what's the technology flow, what is involved in the what are the technology components that are actually in this particular technology stack deployment. Sometimes we've had, well, we need to have this and this and this and this in our technology stack, and it's kind of a kitchen sink effect. If you're applying a more organized architectural approach to it, which includes threat modeling, you start seeing the relationship of all of the technology needs that were actually being met and what are the security risks that are coming to surface, or potential security risks that are coming to surface from that. So what is threat modeling? Threat modeling is the idea of applying evil think, but in a rational or a more methodical approach. It isn't just sitting down and having a brainstorm by yourself about, gee, how can I break this? This is about actually decomposing the architecture, the technology stack that you're working with, and examining what kinds of security issues can be created. This isn't about actual vulnerabilities. This isn't about the exploits. This is about examining the potential issue that can arise, and so that you can bring to bear the right security requirements or right controls to then mitigate that potential problem. But it's definitely about decomposing that architecture. This is a key process in secure design. If you are simply looking at it as, hey, we've got this list of policies and standards and we're going to throw everything at it, it's overkill. And so basically it's that kitchen sink idea. So you have to really look at what can go not only wrong, but what's the potential impact to the business, and having a clear understanding of the assets involved. Don't isolate your thinking to the assets as being the data. That data definitely can be an asset, but depending on the type of data, the importance of that asset is going to shift. Also, keep in mind that there are other ways of looking at assets in your technology stack. You're looking at a business process. Can I use that technology stack to break the business process being the asset? Can I leverage that technology stack? I don't care about the data that's in there. I am simply going to plant an army of bots in this cloud environment and launch my attacks using this corporate technology stack. So assets are various, and they take and they're going to take different forms and different importance depending on the context of the business. As you're looking at those assets, you're going to see a connection then as well to the motivation and the class of actor and what they're bringing to the table to actually conduct the attack. And so that also is going to play a part in how you're evaluating those threats on the basis of the value of the asset, the motivation to conduct the attack, and then being able to bring to bear the correct set of mitigations or potentially risk acceptance, because you will never find yourself fixing everything or bringing some sort of control for every possible threat that you'll find out there. There's a slew also of different approaches to conducting threat modeling. And like I said a little bit earlier, there's a lot to talk about in the cloud and threat modeling topic, so we're going to narrow that down. There are plenty of resources on the internet that you can look at for some of the different methodologies. I just happen to be a supporter of FAST, which which happens to be the thought process that we've adopted at ThreatModeler. But again, there are different ways to approach this, and you do well to take a little bit of time to look at some of the different approaches and the evolution of threat modeling. The key, though, is understanding the composition of the technology, understanding the assets, and the relevant threats, and being able to distinguish amongst those threats which are outliers and which are realistic threats and which ones are really valid or worth investing controls and security requirement implementation. Threat modeling, by the way, is used extensively by the larger cloud service providers. And so they are engaged in these same processes as well. So how do you do threat modeling? Well, over time, threat modeling has been a very labor-intensive, complex process that would take weeks potentially of preparation, that were exercises with a very large whiteboard in a room with 20 people, that could easily devolve into not only talking about the security requirements or the threats that are being identified, but actually debates around, well, this isn't really how we constructed it, and our standard says we should do it this way, but we actually took this other technology and implemented it differently. And so you get a ton of spin in these discussions with a limited amount of deliverable. The limited amount of deliverable in these older ways, or this older way of doing it, has been due to the lack of automation and the lack of good tooling to be able to conduct these exercises. And so you have issues with how are you translating this architecture into something that everybody's going to agree to, that becomes a form of a blueprint going forward that clearly identifies the threats, that clearly identifies where we should be having security requirements or controls drafted and from there implemented. And then being able to communicate that to the operators, the people that actually are going to implement the mitigation. So that collaborative effort has, as you can probably conclude, been really difficult to bring out of a waterfall methodology. You could have these kinds of engagements that would last 4 hours or 8 hours over a day or two, and then go back to the drawing board and refigure it out, and redo your architecture, and then be able to move forward. Well, in the rapidly evolving technology deployment space that we have now, that's cost prohibitive. And you're not going to get the collaboration. Nobody's going to sit down with you and take that kind of time. So threat modeling has had to evolve. In a threat modeling process, you should have some key elements identified. You should have a good way of representing the threat model, whether that's diagramming, which I happen to believe is a necessary piece of this. You need to have clarity around the technical components and what granularity you're going to with the technical components. And the deeper the granularity, the more complex the exercise is. And so if you're getting to a point where you're mapping data flow in UML between functions, you're basically coding the application at that point. And so you're now taking this to the right instead of to the left. And you have to have clarity of what the assets are, or what they can be, and what is the attacker seeing as assets. Once you've gotten these pieces together, then you go through that exercise of actually identifying the threats. And the threat identification can take a little bit of a form of a brainstorming exercise. And and you can spend a little bit of time on some really crazy potential threats. As an example, if I was threat modeling a car, for example, I'd be looking at this as, okay, I've established that my car needs to be armored, and it needs to have chaff, and it needs to be able to evade missiles, because there is the potential, perhaps not probable, but possible, that somebody's going to shoot missiles at my car. Well, yes, that's a possibility. That is a threat, but it's not a realistic one. And so that's where you start looking at the context again of the asset. In my case, I don't need a car that is equipped that way. Leader of a country might. And so now you're looking at the context of the asset to determine what is the threat that's realistic. But you need to keep it to the realistic threats. Otherwise, you're going to be trying to boil the ocean and deal with threats that are either of low impact or so unlikely that they're not worth the amount of investment necessary to mitigate them. I want to jump back to the diagram. There are several methodologies that approach threat modeling without a diagram, and although I do kind of get some of the benefit of potentially the speed of doing this on the basis of just a questionnaire, it does limit your threat model in a couple different ways. First of all, when you're looking at your threat model and you're doing this assessment, whether it's during the threat modeling exercise itself or as you're moving that blueprint forward to be able to make sense of the architecture and why some of the decisions are being made, you need to keep in mind that the visual representation is about 50% of how we do processing. We process a lot visually. And so not seeing that architecture and the relationship across the technology stack, whether that's horizontally or vertically, you start missing nuances of attack path. You start missing nuances of the business process or the technology flow. And you don't you don't have the ability then to see logical flaws that may present themselves as that are threats to the technology stack or the process, and therefore then become potentially exploitable weaknesses through process and people. And we've got plenty of tools to deal with the technology vulnerabilities, and so you can take a less visual approach for those because those are more easily canned. But that logical aspect of the technology stack flow and the process flow that's being supported by the technology can be easily missed then if you don't have a visual representation. At the end of the how is the results, and being able to not only have a list of threats, but you need to have this list of threats that don't just sit on somebody's shelf or in somebody's drawer as a Visio printout. You need to have this as a set of data points that are translated into actions that during your coding or your build phase are then actually implementing controls and security requirements to mitigate those. If you can't get this to the operators, and you'll hear me say this later in the conversation, if you can't get this to the people that are actually doing the work, then or that they don't understand it, then we've missed the boat with the threat modeling process. So persisting that threat model data is a key piece of how to do this right. The data that you're pushing, the security requirements and the controls, need to be stated in a way that it's easy to implement them. The wording, the way that you're delivering this information needs to match with whatever policies and standards that you've made statements around, because that's what you're being held accountable to. They need to be not only understood by the people engaged in the threat modeling process, but they need to be understood by the people who are evaluating the results of the process, implementing the process, and measuring the security posture. So the measurement aspect, I'm thinking more along the lines of people who are engaged in governance, risk controls, people that are looking at the compliance, and is what you said really matching whatever you've promised to deliver as far as a compliance framework, whether that's NIST or CIS or PCI DSS, pick your poison there. You need to have that consistency so that everything is, when it's being explained, is easily explained in the same terms, and it gets an easy nod. Otherwise, again, we're starting to slow on. So we would be starting to slow down our development and delivery process. Not only do we need to be able to provide the data, we also need to be able to identify the status of the mitigation. If you're doing threat modeling and you don't track the mitigation, then what you basically said is, here's everything that could go wrong, wash your hands, and good luck. You need to be able to be tracking where you've made these changes to actually either mitigate the threats that have been identified or make risk deferment or risk acceptance decisions. With this data then that we've collected on both what's been implemented and what hasn't, we're able to look at where do we need to continue investing? Are we addressing the right risks? Are we meeting our governance commitments? And these can be governance commitments that are externally driven or our own internal policies and standards. This is a nice basic representation of how we can fit threat modeling into a pipeline. You're in the design phase, you're going to build the threat models. Hopefully you're using a good, a solid tool that can accomplish all of the requirements for good threat modeling, that can deliver the threat model data to your Jira or whatever other tooling you're using for work items, that then can translate into the DevOps or the operators in engaging in that construction, secure construction and delivery. And then the ability to validate the implementation of all of those controls. And that's you can do that validation through any variety of fast, dynamic security testing or static testing or pen testing. The linchpin here, though, is having your threat modeling process not only well defined and supported as a process, but engaging in some form of tooling and automation that is going to speed up your build of the threat model, implementing the design patterns and templates that are coming out of your architecture, and that then enables the push of the requirements and controls into a tooling like Jira. I've experienced a couple of different approaches to this, and that the threat modeling process is going to determine that frequency. If you're doing a lot of whiteboarding in Visio, your frequency of threat modeling is going to be much reduced. You're going to have to pick your points of when it makes sense, when you actually have the time to engage in a threat modeling exercise where the deliverables of the exercise are actually going to be able to be put into that work pipeline so that the mitigations then can take place. Once you've got that, though, the trick is taking that data and actually getting it inserted into the pipeline. So again, if you have a good tool, a good platform from which to do the threat modeling, take the data and dissect the data, push it out to the respective audiences, then you'll have a successful threat modeling in a pipeline. So if we're thinking about this as security by design, we want to be introducing into this pipeline all of the standards and best practices that we may be holding ourselves to. But we don't want to do it as piecemeal. We want to look at this as hand in hand and part of a larger pipeline where the secure design standards, the patterns, the Legos that are being used, the technology choices that have been made are easily consumed inside of the threat modeling process. And so people would already know, what does my technology stack look like? Do I have reference architectures? Do we build web applications following this pattern and using these particular components? All of that becomes really pre-decisioning into that design, and that pre-decisioning of the technology that's been vetted, that architecture has been reviewed, the company is standing behind it, they've invested a certain amount of time and effort to make the choice of this pattern or that technology, and taking advantage of that and making that part of that preparation in that threat modeling exercise. And so if you've got this tooled, you now have templates of that technology architecture that you're bringing to bear. And in doing so, you now have made security decisions, risk management decisions up front. You're not making risk management decisions post, or you're not making a decision to, oh, hey, if we're going to do this web app, we really want to do a WAF here, because if we don't, look at all the issues that we've been having lately. Predictive, shift left, preventive practice. And so the more that you can bring that established knowledge into that pipeline for the threat model, the quicker that your threat model can take effect, and the more easily that you can actually pay attention to the delta, to what's changed in your architecture. And that becomes then the focus for the security architect or that collaborative team to look at, hey, we've introduced this new technology, we're comfortable with everything else, and that extra effort that's needed to make this technology change can be the focal point, and you can trust that the rest of the technology is moving forward as designed. When you're looking at cloud, there's a piece of this that's already coming into play. When you're going to select your cloud components, and you're building out your infrastructure, you're making choices for what services, what's this going to look like. And the cloud providers have designed this as a very menu-oriented almost, in a way where I can go and pick what are the services that I need, what are the things that I need to meet from a compliance and best practices point of view of the world. And so that pre-decisioning is really actually, in certain ways, making threat modeling an easier process in the cloud. So instead of us fearing, oh man, we've got to do threat modeling in the cloud and it's all moving so much faster, well, let's look at this a little bit differently. Let's take the perspective of our cloud providers are handing us the tools that are vetted, or we can rely on them. And the assumption should be that if you're moving into a particular cloud provider, you've got a degree of comfort and warm fuzzies with their security model and how they're approaching security and what they're doing for it and what services they provide or don't provide, and that there's clarity in the shared responsibility model of what they do or don't do within the respective security services. So really, this helps us, and this is going to help us speed it up. And so the better that we're incorporating our threat modeling against what are these known factors that the cloud service provider is bringing to the table, the easier our job is, and the better job that we'll be able to do focusing on what is new or unknown, or not well known, I shouldn't say unknown. Let's go ahead and move on. We've really kind of touched on all of these in a couple of the other slides already. So what does successful threat modeling look like? Well, your process and your approach to threat modeling will have been adapted to how you're doing your development. What's your life cycle look like? How does it fit in that pipeline? Where is it fitting in the pipeline? And is there an underlying pipeline that feeds that one? As we were talking about your architecture standards and policies and standards all coming into play. It has to be collaborative. If you look at threat modeling as just, hey, it's the security architect's job, we're missing the boat, because the security architect knows security, may know the architecture really well, or may know how to deal with examining and assessing an architecture, but he doesn't have necessarily the insight into all of what's sitting on top of that, as far as business process, as far as the assets, as far as how is the business looking at risk management, risk acceptance, what are they concerned about? And they need to be looking at how they're going to communicate with the different players in this pipeline. They need to have good communication with the people that are establishing the Legos, the components, the standards and design patterns. They need to be able to take the fruits of their labor and pass that on to the operators who are implementing the recommendations. They need to be able to talk to other people in the information security team or technology deployment teams and speak to how the deployment has actually gone. Is this blueprint looking like as built? Is the blueprint just as designed? Or are we looking at this in terms of, hey, this is actually how we put it together, and everything that we talked about during the threat modeling and all of the requirements and controls that were derived from that are not only in place, but they fit the architecture decisions that were made during that were implemented at the end of the cycle. It also needs to fit from a tool chain perspective. Your tooling is really the gearing for the velocity of your life cycle. And so if you are staying, keeping this in first gear the whole time because your threat modeling tool doesn't deliver, or you don't have a threat modeling tool, or you're basically killing your process from the get-go. So you need to look at being able to have automation through tooling. It needs to be repeatable and consistent, and that's achieved through having a good method or a good process that's well supported by the tooling. That's all great. Again, the data that comes out of it needs to be actionable data, and actionable data means that it can't be security ease. It needs to be requirements and controls that are readable, I'm going to say both ways, that are understood by the people who are going to look at compliance and say, oh, okay, I understand what this requirement and how it fits the compliance framework that we're addressing. But the people that are doing the implementation have to be able to read that security requirement or the control, the prescriptive control implementation, whether that's configuration or where to put it, that it's clear to them and easy for them to act on it, that they can actually implement it without having to come back and say, okay, I have no idea what you mean by this. And you have to have a vehicle that in your threat modeling process that is able to talk to the other tools, that's able to relay this data to the next tool in the pipeline, and is able to clearly identify who's the audience in that tool. Am I sending this to the infrastructure team? Am I sending this to a development team? And so that collaboration is supported by the ability to communicate this well. So let's talk a little bit about some of the other values and outcomes that I think are necessary to consider for your threat modeling and being able to leverage threat modeling more fully. Now, we just went through all of the detail, not really detail, but we hit on the surface of what threat modeling is, how you can do it at a high level, and where it happens. And obviously, in your continuous iterative here that you see on the screen, it's clear it's in plan. We know that. Everybody knows that. But threat modeling supports not just good design, it supports the implementation through clarity of security requirements and controls. It supports testing. You can take your threat model, and going back to the earlier statement around the blueprint, if you think about your threat modeling as a design blueprint, and then you look at threat modeling as a blueprint as built. And you really should always be looking at this as having the ability to update that blueprint. If you're a firehouse responding to a building, you don't want the as designed. You want the as built blueprint. You need to understand what are you actually facing. As designed is important. It gets you there, gives you the guidance to go and do the construction. But after the fact, that threat modeling document, artifact, whatever form it takes, isn't just usable in that single phase. You can carry this forward and drive testing against it on the basis of, hey, this is what the business cares about. These are going to be the issues that are showstoppers for the business. These are issues that we are finding in the testing that we shouldn't be finding. We have identified, for example, SQL injection as a threat in our threat model. And we did everything that we needed to make statements around what are the requirements and controls that we need to be implemented. But somebody goes and runs a static analysis or does a pen test and finds SQL injection. There should be a couple of questions. Why am I finding SQL injection? And did we not think about SQL injection from the get-go? Hey, yes, we did. It's in the threat model. Here's how we're implementing it, and here's here's how we're implementing the security requirement or the control. Are we actually doing the right thing in the code? Did we throw a WAF in front of it? Pick your poison of how you decided to deal with that. And now you're finding in the validation process and the testing that you've got SQL injection. Well, is it a failure of design? Is it a failure of implementation? Is it new? Is this a whole new way of doing SQL injection that we now need to go and rethink? There's a feedback loop that threat modeling can help you with as you're using that as both a reflector for the results, as well as being able to say, hey, these are the things that we really care about as displayed in this threat model. And let's focus our limited testing time, whether that's limited time because we're pipelining static analysis or dynamic analysis tools, and it takes forever for some of these things to run. So let's focus those tests on the basis of what we think is really important from the threat model to when you're engaging in the very expensive process of pen testing and looking at how much money am I going to pay, how much time are they going to spend on, and what actually are they going to do in the pen test. You'll find that pen testing can be a very inexpensive, relatively, engagement of a couple $1,000s, but those are very shallow and very automated, and they're often missing much of a human element, to the more expensive tens of thousands of dollars, week-long, 2-week-long exercises where they are taking everything apart, but they because they don't have the context of what they should be looking at necessarily, they're just attacking everything. And there are some parts that are not worth attacking because they're either well established controls, things that haven't changed, to they just don't have the time to hit that particular piece of new technology, new feature that was just introduced. Use the threat model as that blueprint for, hey, pen testing, let's narrow you down, let's make you give me the biggest bang for the buck and really pen test the pieces that are worth pen testing, that we really care about, whether that's because of the business impact or because it's the newer technology. This is the new release pieces. We pen tested 80% of this last year. We really don't need to repeat that exercise. Now, granted, this is a rule of thumb view, right? This isn't something that is a concrete, you don't ever have to worry about it. But resources and time are limited, and we make some of these decisions in this process. So here's the focal point. Threat modeling provides you support in establishing that. So I wanted to give a little bit of a visual representation. Back to the visual. I'm a very visual guy, so threat modeling, providing touch points to and support to other aspects of your risk management. We've talked about the secure design aspect. We understand the threat modeling, taking a collaborative effort and feeding off of established patterns and decisions that are being made either by your office of technology or your enterprise architects, or depending on the size of the company. You'll have a group of people that are making technology decisions that are going to be going forward. And as modern information security people, we aren't the no police. We should be, yes, how do we enable this? Maybe sometimes, yes, but bringing that perspective of, hey, this is higher risk. The decision in the end isn't ours, right? But if we can take that feed from the people that have made the technology decisions and incorporate that into how we're looking at the threat modeling, then we're speeding up our process. We are actually then helping to enforce these standards. We're providing a leg up for those technology decisions to be implemented and implemented in a safe way. The threat modeling exercise is completed. You've got threat modeling results. The threat modeling results really can be used in a variety of areas. And we talked a little bit on the last slide about assessments, the testing aspects of it, and guiding the testing. Threat modeling results also are a feedback mirror back into your policy and your standards. Do you have policies and standards that basically aren't ever used or aren't ever enforced? There's always risk acceptance being drawn out, mitigations that aren't completed, even though that they're coming out of, or mitigation recommendations, security controls and requirements that are being recommended through threat modeling, that when you look at the status, they're not complete. Why is that? Feedback into the policies and standards. Are these then things that we should continue declaring, or are we basically setting ourselves up for an eternal loop of risk acceptance and risk exceptions that need to be filled out. Also, are there new policies and standards that should be introduced during this architecture and design phase with new technology? We're identifying, hey, we're able to focus on the new, and we found that this new technology is bringing these threats, and these are the mitigations that need to take place, and they're not addressed yet in our forms of policies and standards. And so then that in turn can go back to the people that are driving policies and standards, whether they're internally or externally driven, and add that so that the coverage then becomes mandated. We're introducing this technology, we're accepting this technology. If we're going to use this technology, then this is how we need to implement it per policy and standard going forward. Also, we can serve a purpose, and depending on how you do your GRC, but threat modeling can help to evidence that you're meeting compliance. Did you do the threat modeling as the first thing, but then also, did you implement the security requirements that are mandated through either internal drivers or based on external frameworks? Are you actually able to show, hey, we looked at it, we addressed it, here's part of the evidence chain of having done the right thing? Or in instances where you are drawing out risk acceptance or exceptions, hey, we know that we've got that threat model identified that we needed to do this. Here's the risk acceptance or risk exception tied to that. This isn't solved uniquely in threat modeling. That's not what I'm trying to say. But I think that threat modeling results play a part in handing over that documentation that can demonstrate that you're complying appropriately. Doing this, though, requires that you not only have done some of the work up front with the architecture design and such, but that you've actually introduced the appropriate method, the appropriate tooling, and that the tooling meets the requirements of being able to support this methodology and being able to propagate the results to the right audiences. So the end result should be that you're building on a sound foundation. You're doing security by design. You have then in a cloud environment, you have baseline secure configurations by using the cloud services that are available. You're looking at reusability and security architecture patterns, and that reusability is driving understanding well-known threats, how you're addressing those, and that you standardized in the controls and the mitigations that are being applied. That you're able to integrate this into that construction pipeline so that you're not slowing it down. That you're able to do this not just for one project, but for a slew of projects, and to do it consistently and constantly. That your results are reportable. And then that reporting, that you can demonstrate also compliance status, that you can guide other services that are essential to providing that security posture, and that you're doing this at that cloud speed. There's a lot left out there to discuss, but there's a lot of information out there really to get into. So apologies for not diving as deep perhaps as some of you might have wanted. If you have any questions, I guess now's the time. Thank you.
For that great presentation and update on threat modeling. Thank you all for watching and attending. Be on the lookout for future technical webinars in the future.